this is for record and an update. Okay, today I did a test. Okay, this is an improvised prototype for discovering a way to provoke a constant movement using magnets and iron shields. Okay, until now I have discovered that using spiral magnets is gonna provoke a movement. The movement is gonna be from the start, from the beginning of the spiral magnet, and as long as and to the end of the spiral magnet. If the spiral magnet from this point to here is gonna move this distance. Okay, that's one thing I discovered in this prototype. The other thing are the shield, using shields, iron shields, to provoke the movement with the spiral magnet. The shields are vertical and the magnet has to be spiral. Okay, they move. In other video I show it moving, okay. But it's gonna stop in moving. Look. Sorry. This one. This prototype is very bad to make the demonstration. Right now I did a test, and the test with this prototype is not showing very good, but it worked because of the gears. It doesn't move and fast. Okay, I have to make another prototype. This one no. I have to make another prototype that is gonna have a rotor and a stator. And in the rotor it's gonna be the magnets, and there's gonna be the shields too. And in the stator, no, the stator is gonna be the shields, and in the rotor is gonna be the magnets. And okay, and this and the spiral magnets, they're gonna close to the shields in this area. From this, it's gonna close to the shield, gonna go through the shields, like I show in other prototype. It's not gonna move. I'm not moving because I have started another thing. Let me see this. Okay, that one. Okay, it's gonna move forward to in this point. But when it gets to this point, to the last magnet, it's gonna go to the shield there. It's gonna kick back, and it's gonna return, and it's not gonna move in one direction because it's gonna have two forces. One going in through this point to the other side. That's the main force, but there's gonna be an opposing force that's gonna stop the machine after running some time, because the same effect, because it's an angular, the same effect that's gonna have in this direction is gonna have it in the other direction. You see, you're gonna feel attracted here in the shield, but then when you get to this point, it's gonna feel attracted again to the shield. It's gonna go back. Okay, I did a diagram, a drawing of for the possible solution to resolve that, but it has to be with other prototype. I have to construct other prototype. But in the design I did, I noticed that I wanted to try it in this prototype to see if it works. Okay, I installed to resolve the problem. Okay, when these spiral magnets go in the shield's gonna get magnetized polarized, but it's gonna be in the obviously in the negative pole because this one is positive, and when if the shield faces, it's gonna be obviously gonna be negative, right? Okay, what happened? To provoke that it continues the movement, when it gets to the last magnet in the new design, I discovered that I could magnetize the shield with another magnet to make it the same polarity of the spiral magnet. The spiral magnet is positive with the other magnet. I'm gonna make it positive too. So it creates a repulsion. But what happened? That repulsion is gonna be created in the shield because of the position of the magnets and the shield. Okay, I did the test in this prototype because for me in this prototype the only thing that I can demonstrate is about the spiral magnets and the shield, nothing more. Because of the dimension of the magnets are too big and the diameter of the base, the gear, are too small. With this diameter that is too small for this one, I should use smaller magnets. Okay, but anyway, this prototype is no more good for me because it's not moving very well because of the gears. This is the gears are creating friction and it's going slow. Then in the stator and rotor, because they don't have gears, it's gonna move more smooth and more freely. Okay, I'm gonna do the test. Okay, so I put, okay, okay, this is the spiral magnet. It's gonna go into the shield, see? And then I'm gonna polarize the shield with this vertical line of magnet in vertical. It's gonna be the same polarity of the spiral magnet. Okay. These are north, 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 and north. Okay, just the shield in the middle. Okay, then this one are north too. North, 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 and north. Okay. What this gonna create is a repulsion in the back side of the spiral magnet. When it's going through this place to the shield gonna become negative, and this is positive. When it passes to the last magnet, this area here, there's gonna be a space, and the magnets are positive here, and the vertical magnets are positive. Are here are gonna then push the effect of pushing because of the position of the gears. They are opening, and that favors the movement of opening. And inside, no, okay. So let's see the movement. Okay. Right. Okay. Is the vertical. This one is not getting inside too easy because, as I say, because the friction of the gears, and because there was another pair of magnets in the same angle but in a negative pole, and they obviously are feeling attraction. They go in. I have to push it here. Okay, it's the spiral going in, and then it's gonna push it. You see? Yeah, and that's it because these prototypes don't help me do a better demonstration to make a circular movement. In the other prototype, I'm using this concept with the repulsion. I have to provoke a movement, a constant movement, and in the other prototype, it's gonna move and move round and round and round and round. Then I have to make beside that one Beyond that one, I had to make another prototype to create the torque. Torque is the force, torque, and velocity. And when I get that, then I can incorporate this concept to a self-running generator that the design, as I say in past video, is different designs. It's not a common design, it's exotic. It's in a vertical position, and it's a coil with the wounding. The wounding of the coil is different. It's not like a common generator. Okay, let's do the more movement because I had to save this video so I can have proof that it worked for me. For me, this film worked. I'm gonna continue the research, but I need like big diameter plastic. There is a big pipes. I need like plastic big pipes, round, with a big diameter, big diameter. And I'm not finding that in Best Buy. Best Buy, yeah. In Home Depot, they don't have that size. I think that size is like industrial. I have to keep on looking for those size. If anyone watching this video know where I can get that, or it can get me that dimension of pipe, you can post in the comment and I can buy it to pay for it. No, I don't know. Right. Okay, let me do more movement here. Just it goes in, and you push it inside. This one is gonna kick back this one, okay, but that's okay because in the other design, this kickback is not gonna happen. The important thing of this was of moving the backside of the spiral magnet, the backside with repulsion force. See? Okay, go in. He pushes it. Again, go in and pushes it. That's enough proof for me. Again, go in and push it. That thing, this means that the drawing that I did, the design is gonna work. This is the proof. Now I can 100% certain that I can build the rotor and the stator prototype, and I'm gonna know that it's gonna move. It's gonna provoke a circular motion. Great. Oh. Okay. Yeah. Maybe I can put more. I don't know. Attraction, repulsion. Attraction, repulsion. Attraction and repulsion. And that resolved the problem. That means that you can have variation on the design. And you know that if you want to push the spiral magnets, when it gets to the last position magnet, now you know that you can use a repulsion effect in the backside. See? You go in and you push it around. Okay, that same effect, if I could do it in this space, that same effect produce it in this small space, we can see a constant turn in this program. Maybe later I figure out how to do it in this prototype, and then I show you. But I wanted to make this video. It was important for me to know that it works. Right over there, this will continue here. Hey, I'm gonna show you something so you can see that this prototype is not good for demonstration. I'm gonna separate the gears so you can see how smooth it's gonna move this thing. Demasiado. Ok, este leo. Okay, this is the spiral magnet. You see the effect of the spiral magnet, it moves along. I'm not gonna push it in. Whoop. Again. Whoop. Remember, the spiral magnet, this spiral magnet is representing one unit, like in every motor. In every motor, there's a lot of units, positive, negative, positive, negative. Let's say that one pole negative or one pole positive is a unit. In a motor, you have that same thing, but a lot around the rotor and the stator. This represents only one unit. Okay. Okay, I'm gonna do it again. I'm not gonna push slowly. Whoop. It went through. Again, I'm not gonna push. It went through. And then that's the kickback. You see, that's the kickback. And I'm gonna prevent the kickback with this feature. With the new feature I discovered doing the new design for the new prototype. That was gonna resolve this issue. Okay. Let's see an example. Okay, okay. I have to synchronize now with my own hands. Okay, went in, then I push it. Went in, and I push it. Went in, now I push it. Went in, and now I push it, go. push, it's not gonna kick back leg. I'm gonna put it in this position. Look. Okay. It goes like that, right? Then kick back and wait. Look. Go in, attraction. Okay, went in attraction. Now kick it back. Went in attraction. Okay. I have to do the other. I have to do the other prototype. It works. For me, it works. To the other prototype. Okay, until I get the materials for do the other prototype, that is gonna have a rotor and a stator. If I find during that time of waiting, if I find a way to demonstrate it in this prototype so it makes a constant movement, well, I will make another video. Okay, that's the deal. Until I wait to find the new materials. If I find a way to provoke a movement in this prototype using all the concept needed to make a magnet motor, I did it in here. Do it in here. Okay. So that's it. Oi. 23 minutes. It's moving.